So I'll pick up here where we left off, which is on page 428, class example number 2. Let's just show you how you find some of these equivalent forms. So right here it says by dividing numerator and denominator. So what I'm going to tell you to do, we're going to skip this part. I'm just going to have you always find so if you want to divide everything by 2, you will notice that every term is divisible by 2. So what you do to one term, you must do to them all. So if I divided them all by 2, I would end up with 4x over 3x minus 2. So that is an equivalent form. If I wanted to multiply, I could multiply the top, every term by a term. So let's multiply by 2. So I would get 16x over 12x minus 8 if you multiplied everything by 2. Now we're going to do it by dividing out factors. And so when I did that, I would first pull out what was common in the bottom. So copy down your 8x. And on the bottom, I'm going to pull out a 2. That would leave me with 3x minus 4. On the top, just to be clear, I'm going to look for a common factor. So an 8 can be split into a 2 and a 4. And then, of course, I have the x. And on the bottom, I have that 2 and then 3x minus 4. Now, because it's a 2 over 2, and these are all multiplied together, and so is the 2 being multiplied by the bottom, I can cancel that. So what I am left with is 4x over, oops, I made a mistake. When I pull out a 2 here, I should have made this be a 2. My mistake. So I should have 3x minus 2 left because I pulled out the common factor of 2. So you see that these two expressions are the same. All right, which of the following are equivalent forms for the rational expression 6 over 2x minus 1? All I simply have to do is factor if possible. I cannot break this one down at all. There's nothing I can do to it. I can't divide out by anything because what you do to one thing, you have to do to everything. So no matter what you do, this cannot be factored. To make the 6 be a 12, I would have to times the top and the bottom by 2, which would I would have to times this by 2, top and bottom. And that does not work because I will get 12 on the top, but then I will get 4x minus 2, and that does not work, so no. All right. If I was going to try, oh my word, this is a disaster. Okay, if I was going to try to make that into this expression, negative 18 over 3 minus 6x, how could I turn the 6 into a negative 18? You're like, well, what if you turned the 6, let's copy it down here, what if you multiplied it by negative 3? But then you have to multiply the bottom by negative 3. Would that work? Let's try. So you would have negative 18 on the top, and on the bottom you would have negative 6x plus 3. You're like, yeah, it's backwards, but it actually is the same. So we write yes. All right, the next one. What could I do to this original piece to make it turn into the expression 6x squared? Well, I could times the top by x squared and then times the bottom by x squared, because if I do to the top, I must do to the bottom. That becomes 6x squared on the top, and on the bottom I would have 2x cubed minus x squared. Is that what they had? Nope, they don't have a plain old x. So this does not work. The answer is no, it is not equivalent. And last but not least, let's try to get the 6 to look like a 3. So if I take my original and I divide by a 2, so I divide the bottom by a 2, I would get 6 divided by 2 is 3. 2 over 2 is 1x minus 1 divided by 2 is 1/2. And no, that is not correct. So that's just a way to find out. You can just take the original term and try to turn it into what you've got, but you have to remember to do the same to the bottom as the top. All right, consider the rational expressions. 4 over 2 minus x and 8 over 4 minus x. John evaluated each expression for x equals 0 based on his numbers. He concluded that the rational expressions are equivalent. Comment on his conclusion. Well, just because it worked for 0, which was true, we get 4 over 2 and 8 over 4. Those are both 2. Just because it works for one possibility, it would have to work for all of the possibilities. So let's just try a different one. What if x happened to be 6? Let's just try. If x happened to be 6, you would have 4 over 2 minus 6 and 8 over 4 minus 6. Well, this would be 4 over a negative 4. And this one would be 8 over 4. 4 minus 6 is negative 2, which is negative 4. So negative 1 and negative 4 don't work. So it can't just work for one value. It has to work for all. All right, and that is your homework.